in a mini video here just to show you I'm a human being. I'm from Chile. And this is like a Twitch. I'm streaming this live coding session. As you are aware, Monday we had a nasty bug and we work around it for Tuesday. I thought that it could be a good idea, maybe not. I can be wrong, but it can be a good idea to solve that bug live. I don't know if you share the same idea. You can just answer, tell me, no, you're wrong. This can be risky, but that's the beauty of open source. You can check all the code of OSM, the repositories that you uploaded into your virtual PCs. And in the virtual PC, you have everything you need to start developing for OSM. Sylvia tomorrow will be doing a presentation where she is going to give you some instructions to become a contributor of OSM. So now imagine that you are already a contributor, and let's hack this. So the main thing that happened on Monday was that you were using, all of you, the same OSM instance. And because of that, weird things happened. I think we were experiencing instances that were taking more than 5 minutes to be ready, or just fail in the process. So that's not a great thing. And as you can see, now that you have your own OSM, that particular instance was deployed in a matter of seconds or even less. So that's the expected behavior. We already have one suspect, and that is the LCM. And that's why I'm presenting this, because I'm the LCM MDL. That's no coincidence. We already investigate this while you were in the Hackfest. So if you can open you can use Visual Studio or VI or whatever you want, but I like Visual Studio Code because it has a lot of great features to debug. Open the LCM project. You can just grab your folder. I'm going to connect to my virtual PC just to show you how to do it if you have never used VS Code. Let's see. Okay, now I'm at my virtual desktop. I have everything I need because of the script that Mark was posting. If you have any problems to see my screen or whatever is happening, please let me know. And you can just grab the LCM folder and put it in VS Code. That should open the project. So that's the thing you should see. The same thing is happening here. First of all, now that you are there, you can open a new terminal that will open just right away in the correct folder. And we are going to run talks. But I can run it here. This is the same terminal that will open below your the screen, the VS Code screen. So you can just run talks. Oh, I'm in the incorrect folder, sorry. Talks, as Eduardo was saying in the previous presentation, will run all the tests required to check if everything with our code is fine. Fine as the previous test can test, because now we have found a bug that is really nasty and we want to solve. But just to check that the previous test run. Tox also will do a sanity check and check that our code follows the standards that we want to in terms of format. For example, now it's running Flake, and everything is okay. This is just a first run. Tell me if you're running okay at your environment. Tox is already installed, so you can just run it right away. Okay, everything's fine. Now we can proceed to be detected. These things with these bugs is like finding the suspect of a murder where you are the murderer. It's kind of weird, but anyway, because we are writing this code. But as you can see, we have several programmers that are doing this code. So. Okay, now open up the ns.py file that is in the OSM-LCM folder. The ns.py, it's a big file, but it's breaking the it's separated. It's classified by these methods, and we have this method called instantiate. This method is the main method that starts the instantiation sorry, operation. And I think probably the bug is here, because this is the main method that we execute when we want to deploy a network service. And as you can see, it receives the NSR ID and the NSLCM operation ID. So there's an instance that I want to deploy, and there's an operation I want to run. This is the instantiation operation. Now, this method was taking too long. And how we do know that? Because we can debug it with our environment. So if you go ahead and go to the terminal, we saw some of the debug process with Mark before, but I want you to check the LCM now. So we go ahead and put kubectl get pods -n OSM, the same command that Mark was using to see what is happening. I have 0 restart. This is perfect. Now we can go to the LCM pod and check the logs. Because we did a deployment of a basic DNF, we already have some logs to play. As you can see, this is very cryptic, but we can trace back to the instantiation of the DNF. Sorry for my pronunciation. It's weird to say this word over and over and over. Okay, as you can see, a lot of stuff is happening. Big amount delete because I mistakenly put something wrong there. And then you will see something like this one. Debug LCM ns.py, enter, getting DNF RS from DB, Hackfest basic DNF. If you search for the Hackfest basic DNF, that this is the one you are deploying, you will find very fast where the things are starting up here. So this is the task Kafka read receive NS instantiate. So this is the line that starts everything. Then it enters, then it's getting the stuff, then goes like here, and then it follows the next steps until it calls ngRO, that is the next model that it handles how we create the virtual machines, how we create the networks for it, etc., etc. We saw in the logs that between this task and the next one, it was taking almost 5 minutes. And that should not happen. So why is it? So we search for those messages here. And as you can see, there's login text, task, NS instantiate, the same one we are seeing here. The task Kafka read receive, that one. Then we go and we have these stages. Some of the stages you can see it in the OSM dashboard, but some of them, like this one, you will not see it unless it fails. So if something happens between these lines, you will see this stage in the dashboard, but usually you should not see these stages because it just go very fast. So now we have the sync file system from database, then reading from database, then getting the NSR. So as you can see in the logs, the getting BNFRs from DB is, sorry, my wife is leaving the house. So this is real time. This is so real time that everything is happening. Everything can happen, and we are working from home, and we need to make compatible the work and the life. You know, this pandemic has taught us how to work from home and make life compatible with that. So as you can see,
the real as it gets.
What?
This is as real as it gets. Very nice.
Yes, so much real. I'm sweating because this is hard. Like coding really is really hard. So as you can see, the next message from this one, something in the middle was taking up 5 minutes. And now we need to start discarding some options because, for example, this write OP status, yeah, it's summer over here and it's really hot. It's not a heat wave, but it's almost close to that. And I hate heat. I love winter. So with Visual Studio Code, you can just click here and press F12 or go to definition. And it goes to the method that we're clicking. So as you can see, this is just an update operation. It's not so suspicious, right? An update operation in Mongo should take milliseconds, not 5 minutes. Then write NS status is almost the same. It's a dictionary, and then update DB. Again, an update to Mongo should take milliseconds. We go back to the same lines. If you want to follow just my screen, you can do that, but you have now your own environment to do this by yourself. So you can do this with your virtual computer and using VS Code. Remember, we are at ns.py inside the OSM LCM folder. And then there's this line. It's a sync operation. Yeah, it's a slagger in the virtual PC. That's why I'm using my own copy of the LCM, because from Chile the ping is really horrible to the virtual PC. It just disconnected. But anyway, I'm connected through SSH, and this is the same instance. I like SSH. I'm comfortable with the terminal. I hope you like the terminal too. The terminal is your friend. It's not scary. These logs are scary, but you can understand them with the help of us. And if you don't understand something, just ask it, raise your hand. You can interrupt it at any minute. Please feel free to interrupt me. So there's this sync. This is kind of suspicious because it has a to-do. I don't like to-dos. Make use of partial sync only for the needed packages. This is suspicious. So if we want to follow this, we will need another repository. This is in the common folder. So if you want, you can open another Visual Studio Code window and put the code, the common code there. I will show you how. I'm trying to connect. Okay, we are here, and you can just right click, no. File, new window. It will open up another window. Feel free to open up several instances of Visual Studio Code. You have plenty of RAM to do that. And then in Git, you will see a common folder. And this is a library that NBI, LCM, and other modules uses to put the common stuff there. It's a really handy library. In OSM Common, you will see an FS local and another one that is called FS Mongo. Both of them inherit from the FS base. And as you can see, FS base has a sync method right here. And you will wonder, okay, we have FS local and FS Mongo. Which one are we using? If you go to the LCM and FS sync, you will see that this one, the self FS, and you can use the search here, FS. Okay. Here, instance, this is the test one. Okay, here is the help connection. Okay, there's another file that is called lcm.py in the same folder, OSM LCM. It creates the file system here, depending of the configuration we are using. Because, okay, here's the one, the storage, and here's time, here's connecting to, okay, file system, go to file system, this is data utils, here one. Okay, now we are at filesystem.py with data utils. The code here is when the LCM module is starting up, it reads the configuration you are passing it through environment variables or with a file, and it checks if it needs, for example, to connect to MongoDB and which one is the URL is connecting to, or if it's using Kafka or the local message or whatever. It just starts up the LCM model. And if you go to file system file, you will see that if we are using config storage driver local, it will connect to FS local. But if it's using config storage driver Mongo, it connects to Mongo. I don't know if you're aware that MongoDB has a driver that allows you to store some files there. It's called GridFS. Who is aware of that? It's something completely new. Yeah, Eduardo is saying I am. Yeah, I know you're aware of that. But anyway, the MongoDB is ready to accept files, and we're using it as a storage for the packages. So, how we know which one we're using? Let's go to the environment. Tell me if you can't see the screen, please, if you have problems with the screen, because I'm using a really big font. So now we are going to write kubectl edit deployment LCM. I'm going to copy this line and leave it here. And if we go down, you will see that the OSM LCM storage driver is Mongo. Okay, that is giving us a clue. So it's using FS Mongo. Now let's go to the common library and open up FS Mongo. And let's check for the sync method. The sync method goes here, and it has a from path known, update local FS, and if from path is none, it just go and pull and checks for all the files in the database and writes them to the local file system. That's something we don't want, right? Who else is seeing a problem here? What happens if all of you, like on Monday, were uploading and trying to instantiate your packages from the NS and BNFs that you wanted to deploy? It's a nightmare because you were, I don't remember the number, but it was close to 100, right, Mark?
Well, yeah, we have good 50 people working simultaneously, and there's, a couple packages that were being uploaded at a time. So, yes.
Yeah. Okay, so that gives us like more than 50 packages at the same time. So if we multiply 50 packages by 50 of you working on this, it's a lot. It's not something we want because this is going to be executed. Let's go back to the file we were checking up, the ns.py. I have a button in my mouse. If you press it, you go back. That is really handy for these things, these kind of things. So as you can see, sync doesn't have any parameter, so it's doing this for every single instantiation you were doing that Monday. That's kind of a problem. So let's see if we get something we can work on with this FS Mongo. As you can see, the sync method receive a parameter called from path, and it filters out the directories or files that we don't want to update. For example, here it's getting a file, and if it doesn't start with the from path, it's discarded. It just doesn't execute the sync to the local file system. And some of you were, I think, are wondering why we need to sync with the local file system. Because, for example, for the charms, we need the whole package in the file system to be ready to deploy as a charm. You saw the presentation of charms, so, and Mark knows better about this, but they can be really heavy. I think the one you were uploading, it was 25 megs. It's a lot of data. So, yeah, you were saying something?
Yeah, I was about to say, yeah, some of the packages were rather large until we started trimming them down for Tuesday.
Yeah. So if we do the calculations with Python, it's 50 of you, at least, 50 packages, at least, by 25 megabytes. It's a lot. Roughly 62 gigabytes at once, at the same time. No computer can handle that really fast. So we need to filter out, and this forum path seems handy to do that. But how we can examine that? Here, yes, I know how it works behind, but I want to show you how you can just be aware of this and how you can figure out how it works behind the scenes. Now we are going to go to the terminal where we were examining this file, how LCM is operating with the storage driver. And we are going to go to the database and check the descriptors that were stored in the database. So now we run a kubectl, get pods.n OSM again. And as you can see, we have the Mongo here running. And we are going to do an exec-ti and OSM bash. We're going to open bash on Mongo. I'm going to copy this line into it. I want you to debug OSM, so please go ahead and enter the database. Now inside this pod, type Mongo, and now we are inside Mongo. I always feel like in the matrix with this, because you go inside a computer, then inside another computer, then inside another computer. It's like a meme, or you can just feel like Neo hacking something, or Trinity. So we are inside Mongo, and as you can see, we are in the primary node. Now type use OSM to change to the OSM database. Container inception, yes. I don't like Inception, the movie, because I saw another movie called Paprika, and it's really an improved version of Inception. But that's my movie critic takeaway. Okay, now we're inside OSM database, and you can type db.ns, and if you press tab, you will see these collections. Now go ahead and type nsds, find, and you will see the descriptor that you uploaded before with Mark. Now, This is the descriptor that is stored, and it has something extra besides the things that you were seeing in the descriptor YAML. As you can see, there is something called admin. I'm going to copy this and format it in a better way. JSON pretty format and validator. Okay. Let's go. Okay. Now you see the admin there. And as you can see, it has metadata that OSM uses with the descriptor. And it has this one that it says storage, fs mongo, the thing we already know, and the path. And this is the folder. And if you check the folder, it seems like a Mongo ID. Which Mongo ID are we using? Let's check here. And oh, surprise, it's the same ID the document has in the database. So if we know the ID of the NS descriptor, we know already the folder. And the same goes with the BNFs. So if you go ahead and type dd.bnf, and it auto-completes to BNFDS, fine. And you will see the same thing here with admin and the storage. And the ID here is the same one that we see here. So now, how we can fix this error, that we are updating all the packages and not only the ones that we want to instantiate? Maybe we can just update the BNFD and NSD we want to use. And as we know now, the folders that we want to update are the IDs of the NSD and the BNFD stored in the database. Nice. Now we have a solution for our problem. So we go here again to the only suspect that maybe we are just now sure that is failing, and we need to fix this. So how we can fix it? If you go below the code, you will see that here is just a preparation of all the data we need to do the instantiation. So at some point, we are getting the NSR, and the NSR will have the NSD, and we can get from the NSD from the database. The same thing we did manually in the database. And as you can see, we have the NSD ID. It's the same one that we were using as a folder. So maybe here we can just go and put here, and we can just use the NSD as a folder. And that's it. This is just for the NSD. We need now to go and update the BNFD we are using for this particular NSD. Let me check if there's any message. No, everything's right. Remember, you can interrupt me at any minute if you don't understand this. I'm trying to be as clear as possible because this is a huge code base. It's a monster of a project, but with these pieces you can get some idea of how is to develop for OSM and how we fix some bugs. Now we are fixing it live. I don't know if it will work. I'm crossing my fingers. I'm really nervous. I haven't tried of this, but anyway, it's a good example, and that's the beauty of open source. If maybe with this we don't fix the bug, maybe some of you gets an idea of how to fix it and then upload it and contribute to OSM. Maybe. I don't know. So as you can see, we have the BNFR and the BNFD, and it goes the same. It's the same ID we need to update. It's the ID that Mongo is using to store the BNFD. So maybe if we put the sync here, it will work the same as before. So use the BNFD, and that's it. Now we need to get rid of this nasty line of code, and we are going to delete the stage 1 because it's not the stage 1. Now it's kind of in the middle of the other stages. It's just data we need to sync with the packages and all the data extracted from the database in order to work and instantiate the NS and the BNF we want. So now we sync only the NS we want and the BNFD we want to the local file system. I think it's a good solution, but we need to check if this works. So we're going to go ahead and run talks again. Remember, this is, and Mark did a beautiful presentation about tests before. If you have any doubt, Mark is here and you can ask him. But the beauty of the unit test is once we have a good set of unit tests, we can run them again and check new code if it's working with the old stuff. And now that we have a change here, we need to check if the tests are not broken. Let's see what's happening now. So I need this line. Don't mind it. It's not for you. This is just for my environment to run talks. Python. You just type talks and it will work, please. Now we check talks. We did 3 lines of change. First, we deleted here. I am going to put the diff while the talks is running. With Visual Studio Code, this is really easy. You just type. You just put this button, push this button. I think we need a extra package with Git, but as you can see, I put this new line here at the 1681, and this one here at the 1697. So what we're doing is sync this. Yeah, I can paste it and delete this one. Okay, I'm going to paste from try until this comment. Okay, I'm going to paste it into Hackfest. If I look to the left, it's because I have a second monitor, but it's really far away, so sorry about that. Okay, I have pasted the portion that we're modifying. You can grab it from the Hackfest. Okay, as you can see, we have talks putting all the green flags here and telling us that we are doing right. So this modification in the instantiation process is not harming the test, the unit test. And we have plenty of instantiation tests, so I think we are in the right path. Now, you're wondering how we test this. So we have, this is the caveman method, because then Eduardo is going to do present a better way to debug this. But when we want to test it with the system as a whole, we need to do a new container. So for LCM, at least, you will find a Dockerfile local. Why it's called local? Because it's for you to create a new container for testing purposes, and it has all the right environment variables and all the stuff that you need to build a new LCM container from scratch. So for this operation, you will run this command, sudo docker. Oh, it's really big. I can see the thing I'm writing. Okay, sudo docker. This is not for the. Oh my god, I have done a lot. Sudo docker build .f Dockerfile local dot and then no cache. The no cache part is really important because we don't want to some layers of Docker messing up with our new build. Sometimes Docker catches some parts of the code and or in another layer, so we want a clean container with our changes, with our new changes. So go, I'm going to paste this line. Execute, it will take a while, but this is a new LCM build. Now, who of you have a personal Docker Hub account? Okay, Olga. If you don't have one, please, you can create one for free. So the next step, you can just look at me, or you can use my container inside your virtual desktop. But this is the standard process. You are now creating a new LCM module. My computer is working as hard as it can. As you can see, these bars are the processes that is running. I hear the humming of the fans spinning up. It's kind of beautiful. Maybe I'm a complete nerd, but I find it amusing. Okay, now it's reaching the final steps. It's building up all the dependencies. As you can see, it's cloning common to the repository we already saw. It's adding the local, the environment variables. And it's complete. Or not. Okay, now it's complete. We can go ahead and tag this, Docker tag. Let's call it LCM Hackfest. uno, or one, sorry, my Spanish. My Chilean persona is always trying to come out. We can go and push this. I'm pushing it to my personal Docker hub. You can do it with your personal or maybe the company repository. Remember, this is open source. You are free to do whatever you want to with the code. If you want to contribute, you're free to do so. Now I'm building my own container. That's total gospel. I want you to create your own containers and upload them into your personal accounts. Joe is asking if not sure if I understood. Are packages loaded? Yes, they're loaded as files to MongoDB because the packages are not only consist of only the descriptor inside. They have a lot of other files, as you can see in the repository, the OSM packages. So if you go to the OSM packages, let me check OSM packages. For example, open up any of them, you will see that it consists of a lot of files besides the descriptor. So where we can store those files. One simple solution can be the local file system, but the local file system has a problem that if you want to put OSM in a cluster and have different instances of LCM, you cannot do it because now you are using the local file system. So one solution is to use the file system Mongo provides that is called GridFS. And that's the thing we are using. But when you are instantiating something, for example, a particular instance of LCM is trying to do the instantiation, it needs to grab those files, put them locally in order to deploy, for example, the charms or the execution environment to Kubernetes. So that's the step we are trying to fix now. I don't know if that's...
Basically, what Mongo is doing there is allowing you to have a sync between all the between NBI and LCM in order to have that file shared between those two components. And it also allows you to share between instances of the same component. That way you don't need to have a shared volume across all those instances and taking care of that synchronization.
Yeah,
and the rest, Fabian is completely accurate.
Yeah, sorry. The sharing of a volume between different pods, it's hard. Solutions to that is like NFS, but it's a hard problem, and you don't want to share volumes between pods in a cluster environment. Now you have an OSM that works in a single node. That's why you can just go ahead and change the storage driver to local, for example. But in a cluster environment, you can't do that. You can't do that. So now we have our custom LCM uploaded to my personal account. This is the container address. And now we are going to go to our virtual desktop in the terminal, and we are going to change the LCM image. So go ahead and, yeah, Eduardo is right. It doesn't make you install the specific CSI to support that as well. So it's easier to use something like MongoFS instead of trying to share a volume. from maybe the programming standpoint, it's easier to do the second option, but from an operation system, a system operator standpoint, it's kind of hard. So let's go and write kubectl, edit deployment. We are going to edit the LCM deployment. And if you go to the line that specifies the container we're using, this one with the image, as you can see, it says open source MANO LCM testing daily. We're going to delete this and put our custom image, the one that we created with the fix. Nice. Is that clear? You can do it in your own environments. Let's save this file. And as you can see, deployment extension LCM edited. Now we watch the pods. And as you can see, LCM is now initializing. It will download my custom container. And if you put that or your own container, it will do the same. It will download the image and then deploy the container. So now it's initializing. Once it finishes initializing, it will destroy the other pod. Let's check. It's in Whitestack. Okay. Now it's running. And the other one, the old one, is terminating. Yeah, Eduardo is right. Sometimes it's also a good idea to change the image pull policy to always. Okay, let's wait to delete the pod. Now we are running with our custom LCM in in your own OSM. So now what we're going to do is list the NS we have deployed, the one we deployed with Mac, and delete it. Or with OSM NS delete, and the instance name. So now, once it's deleted, we're going to execute again the instantiation line with ns create, ns name, nsd name, with the Beam account that you're using, etc. Please don't use the same line as me. Change the Beam account, please. And let's see if it works again. Now it's building, it's building, and it's ready. So just, I think, on time for the end of this session. Now we have again a new instance of the basic BNF ready, but using our new code. So finally, now that we are happy with our fix, we are going to commit it. Now, this one, you cannot follow it. Wait until the presentation that Sylvia will do tomorrow of how to contribute to OSM, to receive the instructions of how to become a contributor and how to commit new changes into LCM, for example, or NBA, or any node of OSM. Now, how we can commit? Eduardo did in the past presentation, he pointed out all the steps you have to follow to have the repository ready to do a commit. You have to follow all those steps. I have everything ready here in my machine. So we have in the status only this modification, git diff. Okay, the diff is okay. And now we can just add and commit the changes with a -s, because any change that goes into OSM needs to be signed out by the committer. So with -s, -m, a message, fix FS, sync problems, fix it using syncing only the particular NSD and DNFD that the instantiation needs. Okay, now we have the change, and now we can do the push operation. First pull rebase, and then git push. My username, please don't copy the password. And now we have a change submitted into OSM. Wow. Now we can open up the link. As you can see, Gary change has been submitted. Here's the message. Here's the change. I know I'm the LCM MDL. I need to approve this change, but I always ask someone else to review it. So, and then also we need to wait for Jenkins to run the robot test for this one, for this change, and give the +1. So those are the final steps, and once the MDL approves, after the review of Jenkins and other person, it will be merged into the master branch. So we're now at the end of this presentation. I don't know if you have any questions. I can refresh, yeah, refresh the page. Okay, Eduardo is already giving me the +1. Thank you, Eduardo. So we need to wait for Jenkins, but this was as real as it gets, as Mark said. The colors are coming back to me. I was really nervous for this presentation because it's really real, the struggle is real, the bug is real, and this fix is really real. And as you can see, it's already submitted into the LCM code base. Ask
I guess
anything.
Jenkins will work during the break.
Now Jenkins is working. It takes a while. We can see the Jenkins working here.
Yeah,
Don't
show the
copy
console
my
output.
password.
So
It's checking out. Yeah, it's in stage 2. It's running cover right now. So the same thing that we were running with talks, now Jenkins is running it inside the Jenkins environment.
So the next things that happens after that is it will run the stage 3, which does perform a full installation of OSM, and it takes about half an hour to complete. So I think that brings us to the break. Or was
Yes.
there? Yeah, okay. So we can check on.
Just tell me if you have any question, because Nicolas was saying that I was struggling with Docker push. Don't push to my repository, just create a new one. And the command I use is just Docker push. It's not an special command. Okay, any other question? If you like this presentation, please the thumbs up, subscribe to my channel. We should do a YouTube channel, maybe a Twitch channel with this live coding session, maybe.
You
Okay,
will be on YouTube soon.
yeah, I'm going to be in YouTube soon. Okay, if no one has any questions, go to the break, because I need a break. I need a coffee. Okay, bye.